There are some special parallelograms, rhombus. So rhombus is a special case of kite. Kite is of course not a parallelogram. So in rhombus, basically it has 4 sides, but all the 4 sides are equal. In kite, the connecting side, or you can say the adjacent consecutive sides, are equal. This is equal to this is equal to this. But in case of rhombus, it is also kind of kite, but all the sides are equal. And the rhombus has all the properties of the parallelogram, as we discussed in parallelogram, and also that of a kite. So a diagonals of a rhombus are perpendicular bisect to one another. That means this is 90 degree and these two are equal. These two are equal. All these angles are 90 degree, and all these, this is equal to this is equal to this. So how to check? Just by saying will not work. We have to prove everything. So this ABCD is a rhombus. So it is a parallelogram also, because we know all the rhombus are parallelogram. That is, the diagonal are going to bisect. So AO will be equal to OC. This OB will be equal to OD. Right? And we need to show that this angle M, this AOD and this 2, these all are 90 degree. So let us take this AOD and say COD, these two. So we know that this side is equal to this side, diagonal bisect each other. This is common. And when we have these two as what this side equal, and because these rhombus we have all equal sides, so this side is equal to this side. So by SSS also you can say that these two triangles are congruent. And when these two triangles are congruent, this angle is equal to this angle. There is x. If this is x, this is x. The x plus x is equal to 180 degree. What do you get? 2x is equal to 180 degree. So x will be equal to 180 by 2, that is 90 degree. So this is 90, this is 90. How this is proved? Similarly, you can do for these two triangles AOB and BOC. RICE is a rhombus. Find x, y, z. Justify your findings. See, this is a rhombus, right? And it has all the property of parallelogram. Along with that, the diagonal bisect in as perpendicular bisectors. Here x is OE. This is 5, so this will also be equal to 5. X will be 5. This is 12, so this will be equal to 12, right? Now this is 12, this is 13. You can also find 5 like this. 13 square minus 12 square like this. So this is how you can find the x, y, z, and z can also be found out. See, this is 12, this is 12. This is 12, this is 5. So this side z square will be equal to 5 square plus 12 square. So this is the Pythagoras theorem. We have employed here Pythagoras theorem. So z will be equal to under root 5 square plus 12 square, that will be equal to 30. Rectangle. Rectangle is a parallelogram which has with equal angles. So this is 90, this is 90, this is 90, this is 90, this is 90. How this is 90? See, if the rectangle is to be equiangular, what will be the measure? See, if these are x, 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 so 4 into x, the angle sum property of a parallelogram is 360 degrees. So 4x into 4x will be equal to x plus x plus x plus x, that is 4x will be equal to 360 degree. So what will be x? X will be 90 degree. So now each angle of a rectangle is nothing but right angle. So a rectangle is a parallelogram in which every angle is a right angle, that is 90 degree. And since it is a parallelogram, the rectangle has opposite sides of equal length, and they by diagonal also bisect each other. This side equal to this side, this side equal to this side. So in a parallelogram, the diagonals can be of different length, but in rectangle, the diagonals are of equal length. So we say that the diagonals of a rectangle are of equal length. How? How to prove it? See, this ABCD, if it is a rectangle, so we have, if we take two triangles like this one, A, B and C, and A, B and D, these two. This is base common. These two sides are equal. You can have it. This angle is equal to this angle, 90 degree. These two are congruent, and when they are congruent, this ought to be the diagonals ought to be equal. This side equal to this side because of these two congruencies. See, these two are different triangles. This side is equal to this side equal to this side, this angle equal to this angle because 90 degree. So AC is equal to DB or BD. That is why in a rectangle, the diagonals, besides being equal, they bisect also each other. We'll take an example here. RENT, this RENT, this is a rectangle. So its diagonal meets at O. We have to find X. If this OR from O to R is this one, 2x plus 4, and OT from O to 2T is 3x plus 1. So what in the rectangle, the diagonal, they bisect each other. So OT is nothing but the half of this OT is nothing of half of ET. Similarly, OR is half of RN, and we know that these two diagonals are equal. So we can just say either this by 2 equal to, or twice of these as equal. So eventually you get 3x plus 1 equal to 2x plus 4. You solve it for x, you get x equal to 3, and you can find out the value. Now square. A square is a rectangle with equal sides. A square is a rectangle with equal sides. Again, it is a rectangle, right? So this is going to mean that the square has all the properties of a rectangle because it is a special case of rectangle with some additional requirement that all sides has to be equal. The square, like the rectangle, also has diagonals as equal. So in this rectangle, in a rectangle, we have seen that there is no requirement for the diagonal to be perpendicular to one another. But in square, the diagonals, they bisect one another. They are of equal length and they are also perpendicular to one another, right? So the diagonals of a square, they are perpendicular bisector of each other. This is also there. So in this square, this TE is a diagonal, BL is a diagonal. All the sides are equal, all the angles are 90 degree, and they are perpendicular bisectors also. So we say that this OE is equal to OT and BO or OB equal to OL. So how can we justify? We can just justify like this. This is ABCD. This is a square whose diagonal they are going to meet at 0. This AO is equal to OC because this is square is again a parallelogram, so diagonal bisect each other. This is equal to this. So by side congruency for these two triangles, that is this AOD and COD, because this is equal to this, or you can say this is equal to this, and these sides are of course equal. Now this angle AOD has to be equal to angle COD, right? This one and this one, so they are 90 degree. So what we have discussed, parallelogram. In a parallelogram, the quadrilateral, because they have 4 sides, the quadrilateral where each pair of opposite sides, they are parallel. This is parallel to this, this is parallel to this. So what are the properties of a parallelogram? Opposite sides are equal, opposite angles are equal, and diagonals bisect one another. When it comes to rhombus, this is a parallelogram with sides of equal length. This is equal to this, this is equal to this, all the sides are equal. So all the properties of the parallelogram along with the diagonals which are perpendicular to each other. Then we have a rectangle. So a parallelogram with a right angle, it's a right angle. So all the properties of a parallelogram, each of the angles is a right angle, and the diagonals, they are equal in rectangle. When we come to square, the rectangle with sides of equal length, all the properties of a parallelogram along with the rhombus and a rectangle. So kite, the quadrilateral with exactly 2 pairs, the consecutive pairs has to be equal. So the diagonals are perpendicular to one another like this. One of the diagonals bisects the other, and say this diagonal, bigger diagonal bisects the smaller one.